Alrighty, we're going to continue our series of videos on bit string flicking, and here we are going to work with examples from Axel, the American Computer Science League. And it's important to note here that these problems we are working with 5 bits only. Okay, so these strings that we work with, they only have 5 bits as far as Axel is concerned, unless they say otherwise. Okay, and in fact, sometimes they'll give this this specification. So first, we're just asked to evaluate this given expression, and so let's just work through this slowly. Let's work with the innermost part of the parentheses. So this is r_2 of not this string, so this becomes 0, 0, 0, 1, 1, just flipping all of those. And then we still have to perform the r_2 of that, and then once we're done with that, we still have to do the L shift or the left shift once. Okay, and then once we're done with that, we have to AND it with the left part. So in the left side here, we use a different color. What we have here is L_1. So remember, that means to remove the leftmost bit and move it over to the right side. So that becomes 1, 1, 0, 1, 0. And we have to still perform the right shift 2 of that result. And once we're done, we still write r_3 of that result, and then those gets the AND operation performed on them. So let's keep on going here. r_2 now, so that means remove the leftmost bit, remove the rightmost bit and move it left. So take this, move it left, get rid of this, move it to the far left side. So r_circ means to remove the right bits and move it over to the left. So now we have 1, 1, 0, 0, 0. Still need to perform the left shift of 1. And then once we're done with that, we still need to perform the AND. And over here, performing the R shift, okay, of 2. So in other words, take this and shift it 2 units to the right. So we're going to lose the 2 right units, and it's going to get filled in here with zeros. So this becomes 0, 0, 1, 1, 0. There's the L_circ3 that still needs to happen. Okay. Okay. So now left shift basically means we're going to take this string and shift it 2 units to the right. So we're going to add 2 zeros to the end here based on our definition. Now, however, when we're dealing with the American Computer Science League, we're working with 5 bits. So that means that this string here, which is, this should only be R shift once. Okay, it's all right. This is only left shift once, not twice. Okay. So now we have a string that is 6 characters long, and normally we only work with 5 bits. So what that means is the far leftmost bit gets deleted as well. Okay. Because the original string, we take this and we push it 1 unit to the left, and we have to reduce it down to 5 bits. So the leftmost bit is going to get lost. Okay. So now we have 1, 0, 0, 0, 0. Over here, we're going to do L_circ, so 3 times. So remove the leftmost bit and bring it to the right. Once, twice, 3 times. Okay. So now that's 1, 0, 0, 0, 1, and then performing the AND. Okay. And remember, AND is only true when both bits are true, so that's only the leading bit. That's going to be false, that's going to be false, that's going to be false. The last 2 is a 1 and a 0. This is an AND, so that's going to be false as well. So the last 4 bits are going to be false. So there you have it. That is our final answer. Now, in some cases, we may be asked to convert this to base 10 and whatnot, but here this is as far as we can take it. Okay. All right, so let's go on now to a little bit more interesting example where we're actually asked to solve an equation with bit strings. Okay, so to solve this equation, what I'm going to do is simplify this expression and simplify this expression, and then work on it from there. So R circ 2, and I'm going to write this string out here, 11011. R circ, remember, means to move the rightmost bit to the front. So take this, circle it around. Take this, circle it around. Okay, so that's what we have. So that's 11110. And then this part right here, that is taking 11011, left shift, so pushing it left 2 units, adding 2 zeros at the end. And remember, we're dealing with 5 bits, so then we're going to lose the 2 leading bits. Okay. If this was like in computer science, where in Java or C, where we have 32 bits, then these would remain. But here we're asked to deal with 5 bits only. So now our equation becomes x OR with this bit is equal to, this bit string is equal to this bit string. Okay. And x can be any bit string we want. Okay. So here's where it gets interesting, because there could be multiple answers. So we have to think through this a little bit. And if you look at this string, the first 4 characters here of this result, they're all ones. Okay, so and then if you look at this, let me write it this way. This is like saying A, B, C, D, E, or with 0, 1, 1, 0, 0 is equal to 1, 1, 1, 1, 0. So we're going to say A OR with 0 gives you 1. So we'll split this up and we'll say A, right, OR with 0 is going to give you 1. What are the possibilities for A? B OR with 1 is going to give you 1. C OR with 1 is going to give you 1. D OR with 0 is going to give you 1. And then E OR with 0 is going to give you 0. So when we look at it bitwise, then we can solve each of these variables by themselves. Okay. So that means that in this case, A must be 1, because if A was 0, then this would not be true. So A must be 1. That's good. Okay. B OR with 1 gives you 1. So B could be anything. Okay. Because if B was 0, this would still give you 1, and B was 1, this would still give you 1. So it could be anything. So it could be 0 or 1. Okay. C, same thing. It could be 0 or 1. D, something OR with 0 gives you 1, so D must be equal to 1. And then E, OR with 0 gives you 0, so E must be 0, because if E was equal to 1, this result would not be 0. So now you have basically 3 bits that are fixed and 3 that are unfixed. So our answers have to fit this following description: 1, anything, anything, 1, 0. Okay, well, we have to, and since there's 2 bits and 2 possibilities, there's going to be 4 different answers for this. Because again, B and C could be anything. Okay. A has to be 1, D has to be 1, and E has to be 0. So there's we fill in all these possibilities: 0, 0, 0, 1, 1, 0, 1, 1. So there you have it. Those are the 4 possible answers to this question. Okay? And that's the interesting thing about these algebra equations with bit strings, is that there can be a lot of different answers. Here, for a contest where you have to solve this in 30 minutes, a bunch of questions in 30 minutes, they're not going to give you too many answers, but they will give you questions where you have to answer multiple, where you have to give multiple answers. Okay, and before I sign off and end this lesson, I just want to pose some questions for you to think about. So we've talked a lot about the nitty-gritty detail. Now it's time to think about some of the big picture issues, like why do we even bother doing this? I know if you're doing this for Axel, then you're probably participating in a contest, and there's some external incentives with that. That's all good and fun, but it's good to think about why we do this and why Axel has these sort of contests on this particular topic. Okay, and these questions will kind of guide you through it. I encourage you to discuss this with your classmates and your instructors. What mathematical operation is similar to left shift 1? So think about that. If I take a bit string and I shift it once to the left, what mathematical operation am I doing? Okay, same thing with right shift 1s. What mathematical operation is the equivalent of bitwise OR, and what is the equivalent of the bitwise AND? And then what operations are similar to L-circ and R-circ? And I assure you that we learn these topics because they are very much related to real computers and how actual real computers work. This is not just some purely intellectual exercises, and it's good to think about why we learn this and how it is connected to the working of real computers. Okay, so this is some good topics to have a discussion and some thought on your own as well. Thank you for watching. Have a wonderful day.